Okay, let's continue. The next question is 1.19. Here, let's read the question together. David can receive one of the following two payment streams. First, $100 at time 0, 200 at time n, 300 at time 2n. Here we don't know n, right? It can be a different, as long as it's different from 0, right? It can be 1, can be 2, we don't know. In the second option, David receives $600 at time 10. So there's nothing unknown to us. We know everything in the second option. In the first option, what we don't know is the year of receiving payments. So here n and 2n are something we don't know. Further information, at annual effective interest rate of I, this is small I, somehow it automatically capitalizes. The present value of the two streams are equal. What we know is this is the nth power of V. V is the 1 year discount rate is given. Determine I. So since n is unknown, since we don't know n, we can't directly calculate compute I, right? If we know n, it's simple, right? So we know the relation between V and n, where V and I. So V is 1 divided by 1 plus I. So this means 1 plus I to the negative n equals 0.75941. Okay, if we know n, obviously we can solve this equation to get I, but we don't know n. And in fact, you will never know what n is. Well, you can come back to calculate, but you don't need to, okay? So as usual, to solve any question from this chapter, draw a timeline. Okay, $100 coming in at 0. Another 200 coming in at time n. Further 300 in at time 2n. The other one is very, very simple. So I only have income at $600 at time 10. So what is the present value? Let's put second. Here my notation means this is, well, if I use the textbook notation, it would be PV10. That means I'm going to convert $600 from time 10 to the present time 0. So what I do is the amount times by the discount factor raised to the number of years I'm trying to discount back. Here, here there are 10 years, so I discount back by 10 years. Okay, what would be the present value of 1? So here we have three income cash flows. So there's no actual notation, so I simply call it the PVI. So it's the present value of all three converted to time 0. The first one, there's nothing I need to do. It's already at time 0. So $100 at time 0 is exactly $100 at time 0. Next, I have $200, but it's at time n. Okay, again, in order to do comparisons of money at different times, we must convert all of them to the same time point. So here we are already at time 0. So now we need this to time 0. We need this to time 0. So in order to get to time 0, we just need to discount, right? 1 year discount rate, raise the power to the number of years. For the same reason, this is nothing but V to the 2n, right? Okay, according to the information, they are equal. So now I have the equation. I don't want to rewrite everything again, so I just put an equality between them, okay? So I just equate them because that's what the question tells me, right? So let me erase this. The question says the two streams are equivalent, so they have the same present value. Now the question is, how can I solve this question, right? So on the left-hand side, I have this. So this I already know is 0.75941 plus 300. The only question is here, right? So v of v to the 2n is v to the n and then square, right? So I simply need to square this about 76%. Okay. That being said, everything on the right-hand side is known, right? So I can actually calculate and divide by 600. So that is a v. And then what do? I take the entire thing to the power of. Let me move this back. Okay. This is 600 crossing out. Take the power of, use a different color. So now the power is 1/10 because I want to cancel this. So this becomes v, right? After I take the power, once I know v, I know I, right? So from this, if I after calculating v, I is nothing but 1 divided by v minus 1. Okay, what is my result? So I got the result of 3.51%. Please check. Make sure you not only know everything, you can actually calculate exactly the correct result, because for the SOA exams, the only thing matters is the correct option, right? Sometimes even you are lucky, that's okay. Oh, the last one. Let me move it to the final page. Okay, take a look. This question is rather mathematical rather than actuarial. Question point 20. The force of interest delta t is. Let me write it in a better way, because I just type and it does not allow me to write things beautifully. So I use piecewise form to denote. So this is 0.04. If my t is between 0 and 5 years, beyond 5 years, it is 0.01 times t squared minus t, and t is greater than 5. Okay, if you are interested, you can check what is the value when t equals 5 from the second piece. Okay, so it's 25 minus 5 is 20. 20 times 0.01 is 0.2. So it's actually a lot bigger than 0.04. So you actually you get a huge increase on the interest at the 0.5. But anyway, what do we want to know? We want to know the present value of $100 payable at 10. Even for a simple question like this, it's still a good idea to write down what it is. So you have $100 at 10. You want to know the present value. So you want to discount back, right? So when you have force of interest, let me introduce a different color to give you another review. When you have, let me put here, when you have force of interest in general form, so I don't even need to specify delta t, I just call it delta t. It can be constant, can be non-constant, as in this case. If I want to move forward ABF, what I do is exponential from 0 to t, delta s ds. So if I want to discount back, well, it's nothing but the negative exponential. Okay. taking the color back. Okay, now what I want according to this. Let me write it slightly below so it does not conflict with the box. I have $100, so I times it in front. According to this present value factor, I will need to go all the way back from 10 to 0. Okay. By the way, here S and T are just notation, right? You can use anything you want because here we reserve T for the up point, so I use S. So you can use something different if you want. In this particular question, the values of delta are separated into two regions, right? Less than 5 and greater than 5. For integral, we know you can break them into sub-integrals, right? And everything just looks straightforward. From 0 to 10 is the same as from 0 to 5, from 5 to 10, right? So of course, here are the negatives. And because you have exponential function, so you can actually separate them. In this case, it's 0.04. That's 5. Okay, it becomes times. That's because A plus B equals E of A times E of B, right? Except that here is negative A, negative B. So I will separate them. That's because they take different forms. Okay. The first exponential is very easy because the constant, so you take it out, is nothing but 5 times 0.04, so 0.2. The second one takes a little extra effort. So you should break them. Let me write everything in full details, just in case some of you are not okay with calculus. So break this, and I have another one. Since this is a constant factor, I can take it out. So this becomes a plus. Okay, keep writing. So copy what I already have. Exponential, constant states. Okay, the power function, so it's t squared. When I do antiderivative, the order goes up by 1, and I divide by the new order from 5 to 10 plus 0.01. The same, right? Goes up by 1, so it's t squared divided by the new order, which is 2. Again, it's from 5 to 10. So I think at this step, you should be able to complete. So it's 1,000 over 125 or 5 cubic plus 0.01. So it's 100 divided by 2. So it's 50 minus 25 over 2. So well, you should be able to get the answer. The final result is about 6.45. I will end here. In the next video, we will start chapter 2. But instead of directly starting the content in chapter 2, I will actually do a quick review of sequence, and will focus on the summation of sequences. So stay tuned. I will see you then.